Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of June 30th this time around, basically the first week of July. So we always start talking about what the moon is doing. And the moon this week starts on the first evening of the 30th into the morning of the 1st. The moon is about 1/3 full. At 10 p.m. or so, you'll find the moon 2 3/4 degrees south of 4th magnitude Sigma Leonis, and 1 2/3 degrees west of 5th magnitude Tau Leonis. Tau is a binary star. There's a 5.5 magnitude star and a 7th magnitude star, very widely separated. 1.5 arc minutes. Remember, an arc minute is a 60th of a degree. We're typically talking about arc seconds, which an arc second is a 60th of an arc minute. So when we're looking at binary stars, we're usually talking about a few arc seconds. So this is an arc minute and a half, very widely separated. You can probably see this with a pair of binoculars. Certainly you can pull it out with any power eyepiece in your telescope and just about any telescope. So this appears to be a real binary system, like the system. They're widely separated, but the systems are actually moving together. That same night, Mars is about 12 to 13 degrees west of the moon, and it sits about 1 1/3 degrees east of 3.8 magnitude Rho Leonis. So a chance to look for some of these stars. The moon's close enough to these stars, Sigma and Tau, that you might have a hard time seeing them. Binoculars are going to help. A Rho's far enough away that you can see Rho sitting next to Mars here. This whole region sets by about 11, sometime between 11 and 11:30, depending on your local horizon. It's not going to get dark until maybe 10 o'clock, so you got an hour window to get out there, look to the west, and see if you can see bright red Mars and Rho Leonis right there next to it. Okay, by a few nights later, on the evening of the 3rd into the morning of the 4th, the moon's now about 2/3 full, and it sits just a few degrees, same time, 10 o'clock at night. It's sitting just a few degrees southeast of Spica, the bright star in Virgo. So then, on the 6th into the 7th, it's already filled out to 85% full, and it's in the head of Scorpius. Being in the head of Scorpius, it gives us a chance to talk about the galaxy. Our galaxy, recall, is shaped like this. There's a disk and a central bulge here. And when we look toward the center of the galaxy, we're looking in the direction of the Scorpius-Sagittarius border, just a little ways east of where the moon is on this night of the 6th and the 7th. We're looking down the axis of the galaxy that direction. In winter, just after dark, we're looking this direction, away from the center of the galaxy. In spring and fall, remember, we're orbiting around the sun here, so nighttime is in different directions at different times. And in spring and fall, we're looking up or down for the galaxy. We're looking to the thin part of the galaxy. That allows us to look out into space and see distant galaxies. But we associate these with this time of year because we're thinking about what it looks like just after dark and not what it looks like just before sunrise often. So now, by the time we get past midnight, the moon will have set for most of the week, especially early in the week. We'll lose the moon interference, and we have a chance to look at some faint objects in the morning sky. But it turns out we've rotated enough that we're actually looking out through the disk of the galaxy, the thin part of the disk of the galaxy, into where we can see external galaxies. That is to say, by the time we get to 2 or 3 in the morning, we are looking at what we would typically associate with a fall sky. Stars rise 2 hours earlier each month, so 2 months from now, the stars will be rising 4 hours earlier. So the stars that are rising at about 2 a.m. or midnight right now, actually, will be rising at 8 p.m. and be well placed by 9 or 10 p.m. And we'll think, okay, 2 months from now, as we get into July, August, transitioning into September, these are well placed in the evening sky, and we're starting to see our fall sky. So anyway, let's look at that. If you look to the southeast at about 2 a.m., you should have Saturn and Neptune that we've been talking about rising into the sky. So Saturn will be this yellowish dot, bright yellowish dot. It sits about less than 1 degree. We've talked about this for a few weeks. It sits less than 1 degree south of Neptune. Find that in your binoculars. You can see Saturn and Neptune. The Great Square of Pegasus lies above here. So you're looking up at the Great Square of Pegasus, climbing into the morning sky, thinking, oh yeah, fall's not that far away, as we see the Great Square of Pegasus. Now, between the Great Square of Pegasus and Saturn and Neptune is Pisces, the head of Pisces, what we call the circlet of Pisces. And just behind the circlet of Pisces, the circlet of Pisces will look something like that. And back over here, just behind the circlet of Pisces, is Omega Piscium, the Omega star in Pisces. about 8 2/3 degrees north of Saturn. If you go about that same distance, 8 3/4 degrees south of Saturn, you get to Iota, Ceti, and Cetus. And so this is a chance for us to find a couple of stars we maybe don't always find. So remember, a fist at arm's length is about 10 degrees, so it gives us a chance. Let's start here to look at Iota Ceti. It's a 3.6 magnitude star, so it should be bright enough to see under most skies that aren't too light polluted or have too much haze or something going on. This is a double star. It does no evidence that this is a binary star, unlike the star we're looking at. And it's over 1.5 arc minutes, so a little bit more widely separated. There's an 8.3 magnitude companion to this 3.5 magnitude star. So this is a chance for you to check it with your binoculars or a very wide eyepiece in any telescope you got. Any telescope you got with the longest focal length eyepiece you can use in there would work, but a smaller focal length eyepiece would work here as well. So now, Iota Ceti. Remember, we're looking at Iota Ceti here, and we're looking, by this time in the morning, the Earth has rotated enough that we're looking not at the center of the galaxy anymore where we were just as it was getting dark with Scorpius and Sagittarius, but we've rotated around so that our nighttime view is up out of the disk of the galaxy or down out of the disk of the galaxy, and we can see galaxies, external galaxies to our own. And one of those lies 1.5 degrees to the northwest of Iota Ceti, Iota star in Cetus. That 1.5 degrees, 1.5 finger widths at arm's length, so you can start with a telescope eyepiece, and if you use a wide eyepiece, you might get a low power. You want to use low power here. You might get this, but scan up this direction and then pause. So move up a degree or so this direction and just pause and see what you see. This is a tricky thing we're working for. We got our bright planets. We've got other things that we've looked at right here, the moon, the planets, and now this is the challenge for those of you who want to get out with your telescope. You probably need at least a 10-inch telescope to make this work. A 12-inch telescope like the one I typically use is better for this, and a 14-inch telescope is going to do you well here. So this is the kind of thing we're talking about, 12 to 16-inch telescope. That's the observing challenge we lay before us. NGC 50, NGC 47, and NGC 54 is going to be a tight group of 3 external galaxies. My guess is you might only be able to see NGC 50 even with your 12 or 14-inch telescope. And so it's going to be the brightest of these 3, and the others may be very hard to see. This is a lenticular galaxy. So we have elliptical galaxies that don't have any free dust or gas, and they don't have a flattened disk. We have spiral galaxies with a flattened disk with a lot of free dust and gas in the disk that can make stars. And the transition point between spirals, we say SA spirals, is the classification of spirals that have large central bulges. This part is large, and you have a little bit less mass and more tightly wound spiral arms. So the bulge is starting to merge with the spiral arms until there are no spiral arms and you have elliptical galaxies. That transition between those two, where you have a little bit of spiral arm and it looks like we're on the verge of calling it an elliptical, is a lenticular galaxy. And NGC 50 is an example of a lenticular galaxy. Now, let's go up the other direction. Our 8 2/3 degrees north of Saturn, and we come to Omega Piscium, a 4th magnitude star, 4.1 magnitude. Again, under dark enough skies, not a problem. And there aren't a lot of other bright stars around here. The circlet isn't any brighter than this, really. And so there aren't, remember, that's this star we're looking at right here. And so if you do the same sort of thing, go 2 degrees north and west of Omega Piscium, just like you went about 1.5 degrees north and west of Iota Ceti, you come to a galaxy, a spiral galaxy now, NGC 7782. Maybe you can see it with your 10-inch telescope. 12 inches or 14 inches is probably going to be better for you. This is in a tight group with at least 4 other galaxies, 7780, 7781, 7778, and 7779. All of these are fainter. So these you may or may not be able to see. You got good dark skies, you got good observing conditions, you got a 16-inch telescope, you got a shot at some of these galaxies. But this is a chance for you to look around and see what you can see in here. So this is a straight up spiral galaxy like our Milky Way. This is a lenticular galaxy. Other galaxies in this region, this is just your observing challenge for the week to go out and look for this. Otherwise, just identify stars that you might otherwise have not taken the time to identify. Iota Ceti, Omega Piscium, and some of these stars in Leo. So that's what we have. Should be a good week. As always, everyone, thanks for watching and have a great week ahead.